Hello and welcome. Today we're taking a look at problem 160, intersection of two linked lists in Leetcode. It's an LC-easy problem. Given the heads of two singly linked lists, headA and headB, return the node at which the two lists intersect. If the two linked lists have no intersection at all, return null. And here we're given an example. So I have these nodes A1, A2 and B1, B2, B3 for the two different lists, and then we have C1, C2, C3, where C1 is the common intersection node between the two lists. And then I have some other examples here with extra numbers, so 4, 1, 8, 8 and 5, 6, 1, 8. 8 is the common node, and then there are two other nodes, 4 and 5. And then we have an intersection here at node 2, example 2. And then example 3 has no intersection between the two lists. So there are multiple ways to solve this problem, and we're going to take a look at well, there's a follow-up here. Could write a solution that runs in O(n plus n time and use only O1 memory. First, we're going to take a look at another solution that doesn't adhere to the O1 memory. We're going to use some extra space. So how should we do this? Well, first we can just check if headA or headB are null. Any of those are null, then obviously we do not have an intersection. And then we're going to say that we need an unordered set. I'm going to call this set A, and I have this node, or I'm going to call it A is headA, and while A is A next, and here we have set A insert A. So we have all the nodes in A in the set A, and then we're going to take a pointer to iterate through B, and while we have something in the list, we check if set A find B different than set A of end, we return B, right? And otherwise we return a null pointer. So if while we iterate all the B nodes, we find the same node as in the set A, then we found our intersection, and that's it, we return B, and otherwise no intersection is found at the end, and that's it. It's accepted, but you can see here that the space complexity, sorry, is going to be O(n). It's not O1 as in the follow-up, and O(n plus m for the time complexity. So how can we improve on this solution? Well, let's go to the drawing, and here if we iterate our two lists, just for A we iterate to the next element, for B we iterate to the next element, next element, next element, next element, and you can see that they get 8 at different times, so that's not good. But now that we reach the end, what we can do is we can set the next element to be the beginning of the other list. So for A, we're at the end of the list A, there are no more elements. So we're going to say, okay, now go to the head of B. And for B, we still have one more element to iterate through. So now we're at 5. And now for A, sorry, we are at node 16B. And for B, we go to the head of A. And then we keep going to the next element. And now you see that the – distance we have from the node 8 is the same for both lists. and we get to 8 with both lists. So we see, hey, this is the intersection, and this works for any list, any two lists. You can test that on multiple examples. You can see this algorithm always works, so it's a nice trick. And let's see how to implement this in code. Okay, so let's take list node A, this head A, and this node B is head B, while A different B to B, and here we're going to say A is if A exists is A of next, otherwise it's going to be head of B, and the reverse for B. So if B exists, B next, otherwise head of A. And again, return either A or B, doesn't matter, and that's it. Accepted. And if we analyze the space complexity of 1, so we've improved our algorithm. So that's it for this problem. I hope you enjoyed it. If you did, like and subscribe, and stay tuned for more C++ problems. Thank you and bye.